This is Lesson 4-2A from the Algebra Readiness textbook. For today's lesson, you'll need your notes packet and a sharpened pencil. Pause the video to gather your supplies and work the study guide problems. Continue the lesson when you're ready to compare your answers to mine. Number 1 asks us which number is divisible by 3, and explain how we know this. We have learned that the divisibility rule of 3 is to find the sum of the digits in the number. If the sum of the digits is divisible by 3, then the original number is also divisible by 3. In this case, 135, 1 plus 3 plus 5 is 9. 9 divided by 3 works out, so yes, that 135 is divisible by 3. Letter B, 7 plus 7 is 14. 14 is not divisible by 3. 4 plus 7 is 11. 11 is not divisible by 3, so 47 is not divisible by 3. 6 plus 1 is 7. 7 is not divisible by 3, so 61 is not divisible by 3. Number 2, is 3,230 divisible by 9? How do you know? The divisibility rule by 9 is to take the sum of the digits, and if the sum of the digits is divisible by 9, then the original number is also divisible by 9. In this case, the sum of the digits is 8. 3 plus 2 plus 3 plus 0. 8 is not divisible by 9, and so 3,230 also is not divisible by 9. Now, the next one, a group of 56 students must be arranged in rows. Each row must have the same number of students. If there must be at least 7 students in each row, how many possible arrangements are there? I like to make a table. Some people like to draw it out. I always start with the minimum number of students or the minimum requirement in each row. In this case, 7. 56 is evenly divisible by 7. If I put 7 students in a row, I would need 8 rows to seat all 56 students, because 7 times 8 is 56. That's not my only option of how to seat students in rows. If I went to the auditorium, instead of putting 7 kids in the front row of the auditorium for 8 rows back, I could put 8 students in the auditorium. And then it would take 7 rows to seat all 56 students. Then using divisibility rules, I figure out that the next number is 14. 14 students in each row for 4 rows. The next number would be 28 students in 2 rows, or 56 students in 1 row. That makes 5 arrangements possible. Today's learning target is to write numbers in standard and exponential form. We are going to use exponents to show repeated multiplication. Here is an example. 2 to the 6th power has a base of 2 and an exponent of 6. This is called a power. The 6 tells me that I am going to multiply the base of a 2 6 times. When you look over here, you can see 1, 2, 3, 4, 5, 6 2's are being multiplied together. When I do that, when I do the math of that, I get 2 times 2 times 2 times 2 times 2 times 2 is 64. That's the value of the expression. Now, this is known as expanded form. This is known as standard form. We'll talk more about those in the next page. So a power has 2 parts, a base and an exponent. The expression 2 to the 6th power is read 2 to the 6th power. So in the expression x to the 3rd power, the blank is 3. So what is this 3? I'll give you a hint. It's either the base or the exponent. Hopefully you see that that is the exponent. In the expression 6 to the 4th power, blank is the 6. The base is the 6. Let's write down a couple vocabulary terms. Standard form. Standard form is the traditional way that we see numbers. For example, 2 to the third power is exponential form. 2 to the third power equals 8. 8 is standard form. Expanded form is writing a power as repeated multiplication. The power of 2 to the third equals 2 times 2 times 2. This is expanded form. Pause the video if you need more time to write that down. Next, you have a chart in your notes. We are going to review each of these powers. We're going to write the expanded form and the standard form. So the first one is read 12 to the first power. In expanded form, that is 1/12. It's not multiplied by anything, just 1/12. So the expanded form and the standard form are actually exactly the same. I want you to take note that how the 12 and 12 to the first have the same meaning. The same thing works with a variable. So if I have a variable of n, that's the same as n to the first power. So the exponent, when not written, is always an understood 1. So n and n. Now, the next one is read or said 6 to the second power. In expanded form, I multiply 6 by itself 2 times. This does not mean 6 times 2. That's a common mistake. So 6 times 6 is 36. 2/10 to the third power. That is the same as 2/10 times 2/10 times 2/10, which is the same as 8/10. Oh, I'm not really sure why I put parentheses around that. We could just write it like this. The next one, -7 to the fourth power. Now this is very important, so everybody, I hope your ears perk up. The base of an exponent, write this down, is only what comes immediately before the exponent. This is going to take this will take an example. For example, in -7 to the fourth power, the base is only 7. Not the negative. That a lot of kids think that it's the negative. It's not. So that negative just stands out front, and then it's 7 times 7 times 7 times 7, 4 times. If, however, there is an example like the next one, -8 to the fifth power, here the base is the parentheses, because the parentheses is immediately before the exponent. The base is everything in parentheses. So you would write -8 times -8 times -8. Ooh, I got to squeeze another -8 in there. Okay, so let's fill out the chart. Make sure you write these notes down. This was very, 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 very important. This is probably the trickiest thing we'll learn today. So in this case, oops, that's the wrong way to do it. So negative sign stays here. 7 times 7 times 7 times 7. Now, $2,401 is 7 times 7 times 7 times 7, and the negative sign is just out in front. On the other hand, negative 8 to the 5th power is negative 8 times negative 8 times negative 8 times negative 8 times negative 8. And so, that's 32,768. And it's negative. The next thing, 5 to the 0 power. We are going to know that if you have no 5s written down, I'm going to prove this part to you later, but for right now, I just want to establish with you that any number raised to the 0 power is 1. Any number raised to the 0 power is 1. Any number to the 0 power is 1. All right, once you have those notes, continue on with the video. A microscope can magnify a specimen 10 to the 3rd times. How many times is that? 10 to the 3rd is the same as 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000 times. Write the expression using an exponent. If there are parentheses in the expanded form, you need to use a parentheses in the exponential form. In this case, what's being repeatedly multiplied is negative 5. I will keep the parentheses around negative 5 and bring that to the 3rd power because there are 1, 2, 3 negative 5s. Letter B. Letter B, I'm allowed to use the commutative property to put that B at the end. Remember, the commutative property simply changes the order of the numbers. Now, using an exponent, I can rewrite A times A times A to be A to the 3rd. And then the B just stays there. Letter C. Letter C looks similar to letter A, but it's a little different. What's being repeatedly multiplied is the 5. 5 to the 3rd power. But there's a negative there, so it needs to be out in front. You wouldn't put parentheses around it because the negative is not being repeatedly multiplied, only the 5. All right, we've done some examples. Now it's your turn to try. Pause the video, do these 3, and come on back to compare your answers to mine. All right, in letter A, 6 to the 3rd power. In letter B, I put 4xy to the 2nd. If you wrote 4y to the 2nd x, that's the same thing. Generally speaking, we always write our variables in alphabetical order, which is why I put the x first. Letter C, make sure that you used or kept the parentheses around the negative 3, so that you are showing or telling the next person that it was negative 3 that was multiplied by itself 4 times, not just the 3 without the negative. Okay, simplify 7 to the 2nd power, and then evaluate negative a to the 4th and negative a in parentheses to the 4th when a equals 2. Pause the video, try these 2, and come on back to compare your answers to mine. The first one was 7 times 7, which is 49. The second one, I'm going to simply replace both a's with a 2. Now, in this case, only the 2 is the base. And so, to write that in expanded form, I would write negative 2 times 2 times 2 times 2. And then this is the negative sign that was just out in front. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. This equals negative 16. As opposed to the second example, where negative 2 is the base and being taken, multiplied by itself 4 times. So, negative 2 times negative 2 is a positive 4. A positive 4 times a negative 2 gives me a negative 8. Negative 8 times a negative 2, negative times negative is a positive 16. So although these that are highlighted, negative 2 to the fourth and negative 2 in parentheses to the fourth, seem to be very similar, you get a very different answer. One is positive and one is negative. So make sure you're being very careful about what they're asking. All right, identify the bases and the exponents. Then write the expression in expanded form. Pause the video, try these 3 in your notes, then come on back to compare your answers to mine. The base here is only the 2 and the y. It does not include the negative. The exponents are 4 and 3. The expanded form of this is a negative sign with 4 2's and 3 y's. Letter B, my base is 8. Most of you will get that one pretty easily. But do you remember that any number or letter without a variable has without an exponent has one, it's just not written. It's a 1. Now that 1 is written there, I bet you recognize the m as being a base as well. So what are my exponents? 3 and 1. The expanded form of this expression is 8 times 8 times 8 times m. Right? And then the last one, negative 6 is the base. Squeeze in the 1 exponent that's not written and the r exponent. So my r base. So negative 6 is a base, t is a base, and r is a base. My exponents are 5, 1, and 2. The expanded form is negative 6 multiplied by itself 5 times. Then t, and then r, and then r. All right, let's check that you've learned what you needed to learn today. What is the difference between negative 3 to the fourth and negative 3 in parentheses to the fourth? Pause the video, show me your work, and then come on back to compare your answer to mine. Hopefully, you know that negative 3 is the base and it's being multiplied by itself 4 times. This gives me a positive 81. Here, only the 3 is the base. And the negative sign hangs out here in front. When I simplify this, I get negative 81 in standard form. All right, give your homework a try.